introduction. Okay, we teach about the idea of the signal and system computation. Okay, this chapter describes both the mathematics functions model for the physics signal and the mathematics equations model for the physics system. Okay, we in the engineering we figure model the system into group. Okay, the first one is the signal in the function or in their natures. Okay, the signal figure is modeled by a function, the math function. Okay, xt, xy, or so on. Okay, and the system that link between two signal or three signal together, figure model them by equation. Okay, equation. Therefore, moreover, the mathematical solution of this equation or the physics system are determined when the system is excited by the mathematical function. This means if you have the system, if you would like to get the output or the excitation or the output, yeah, okay, you must know the input, what about the input is, and you must know about the mathematics of the system is. Okay, by input and by the system, you can determine the output. Yeah, maybe solved by the different equation, maybe solved by the mathematical equation or so on. Now, in order to make you more familiar in the system, the signal, and so on, we following this step. Okay, the first one, the mathematical model for the system. For the system, the mathematical model for the real physics system. In general, the engineering works must usually models two types of the physical phenomena, the physical system or the physical signal by the mathematical analysis. The first one, the system is figuratively modeled by equation. Okay, if the physical system is the continuous or analog. Okay, we figuratively use the differential equation or ordinary differential equation with the constant coefficient are usually used to model this system. And if the system are the digital, yeah, or the discrete system, then the ordinary differential equation with the constant coefficient are usually to use to model this system instead. Okay, this is provide you at the example in the real case. Determine the mathematical model equation of this physical system for the second order linear electric circuit. In this circuit, I assume that everyone already passed the circuit already. Okay, if you already have this, okay, this circuit structure RLC in the parallel, okay, you have the ability to model them. Okay, at the top of that, you can apply the KCL to explain IR plus IL plus AC equal to 0. Okay, from the KCL, the electrical circuits shown in this figure can be mathematically modeled by here. The sum of the current equal to 0, and you express every current in the form of V. After that, you reformulate them. You can see that this equation is become the second order differential equation that can model this system well. Okay, link between the voltage across them, okay, R, L, and C value, where L is the inductor value, R is the resistor value, and C is the capacitor value. Okay, this equation is completely describe the detail, every detail in RLC circuit. Okay, for another ones, okay, determine the mathematical model of the physical system for the second order linear electrical circuit in the RLC in the series instead. Okay, from this, okay, when we would like to model the system, okay, we figure the first step. You can see that the first step we apply the physics system, okay, or the physics equation. Okay, the physics equation may be KCL, KVL, Ohm's law, Newton's law, thermodynamics law, Maxwell equation, or so on. Okay, the first step. After that, you model them. You model them completely. You explain them. Okay, substitute them in the second equation and the third equation step. Okay, is based on your mathematics skill. Okay, to formulate them and to solve it. Yeah. The first one is only the physics. You can see that. Therefore, this subject is belong to the physics and the mathematics skill. The first step, you apply the physics law. The second step, you solve this physics equation, okay, by apply the mathematics skill. Okay, in this case, these equations can link between R, LC, and the current flow into them clearly. Okay. Now, for the circuit, you already passed, but in the engineering, I think everyone not only study in the circuit, you study the mechanics and the other subject. For example, here, okay, if determine the mathematical models equation of the physical system for the moving object that show in this figure. If you put the force to this block, okay, of these objects that have the mass m, okay, move in this distance, okay, what happened if it have the acceleration is at? You can explain them by apply another physics law, the Newton law, the Newton's second law. The moving object shown in this figure can be explained by F equal to ma. A is the accelerator that can explain in the displacement is here, the differential displacement second time, yeah, where m is the mass of these objects and x is the displacement of this mass, and F is apply the force to the mass m. Okay, this is only the example. Okay, you get this, you can see that entire system, you can write them in a single equation that explain everything well. That's why, okay, you can see that this equation is better than you explain by maybe 2 paragraph statements, okay, because this thing will be show you every detail clearly. Okay, now this for the system. Okay, the system. For the signal, what is the signal? In general, the real physical signal are classified in the two natural characteristics, the continuous time signal or the analog signal, and the discrete time signal or the digital signal. The example of the continuous time signal and the discrete time signal will be shown you in here. Okay, the continuous is the green one. Okay, the real signal that you find in the nature. For example, my voice, okay, that is, okay, you may be argue that, okay, hey, Ajahn, the voice can record by my iPhone, okay, therefore the voice should be the digital one. No, your iPhone use the sampling technique and store them in the red one. Okay, the real signal in the world is the green one. Okay, you can see that if you already have the green one, you can sampling them, you get the red one. Okay, but the red one is impossible to construct the green one perfectly. Okay, you must sampling them far enough to store the point enough. Okay, to make the resolution enough to construct the green one back, even though you construct it back, but it's not perfectly. Yeah, if you would like to store the green one perfectly, you must use the infinity data. Okay, but in this case, you can see that because the continuous, it means it have infinity data in the green one. But in this case, you use only maybe 9 points to store them. Okay, 9 points of the data can store that. Okay, this is the link between the continuous and the digital one. Okay, and therefore, in general, the modern technology already implement or process the digital one, not analog anymore. Okay, we will discuss about that topic later. Therefore, in these subjects, the real physics continuous time signal, which are usually depend only on one independent variable time or t, are modeled by the mathematical function such as ft, it, and the vt. Okay. In fact, the real physics quality may be depend on the other parameters such as the position, okay, such as the temperature in your room. Okay, if the location close to the air condition, the temperature may be lower than it usually be. Okay, but in this case, okay, we concentrate only for simplicity. Okay, we assume that, okay, every quantity, every function depend only on time. Okay, the real physics discrete time signal is the same, but the time in this case is the discrete time. Okay, we use n. The n must be the integer instead. The t is maybe any value. Okay, the positive, negative, the floating number. Okay. In the last 2 decades, the digital computer have been extensively used for the data processing because of the powerful performance and the cost effectiveness. The continuous signal cannot process or calculated by the digital computer. Therefore, the continuous time signal must be converted into the discrete time signal or the digital signal by sampling process first. And the digital computers can process only the digital signal, such as the binary code. The sampling rates must be certified the sampling theory or the Nyquist list. The sampling rate will be discussed in the later chapter. Okay. In this case, you can see that if you sampling them too few, okay, you can store the data well, but the number of the data that you store, okay, if it's too big, what happens? You waste the memory to store your data, okay. But if you sampling them too few, you cannot reconstruct the original data back, okay. What happened in the sampling theory, okay? Yeah, I will show you later. Wait a minute. Okay, I will show you about the effect of the sampling. If you sampling the data too few, or if you sampling the data too much, okay, what happened? Can you listen the song? Hello?
No.
No, Ajahn.
We cannot.
No ครับ
Wanna listen?
No.
Okay, wait a minute. Can you? No?
No ครับ
No, Ajahn.
I think you should
You have
share
to
the
share the
computer.
computer audio.
Huh?
You have to share the computer audio. Go to the screen share again and then check mark computer audio.
Oh, I think I already shared it, but I don't know. Wait a minute. Maybe use sorry, a little bit problem. Okay, maybe okay. Therefore, maybe in the next time I will show you demonstrate about the sound quality when you use that. Okay, okay. Don't waste the time to fix that. Okay. Now, if you is mean okay, if you use too few data to store them, you lost. Okay, you lost the content that you can reason them. Okay, but if you store them too much, okay, you maybe waste the memory to store them. Okay, another one application is for example, okay, I think if you would like to download the movie to see the movie in your mobile phone, anyone's download 4K data, 4K movie or 8K movie in your mobile phone? I don't think so, right? You maybe use only maybe 1K to display in a very small mobile phone because the data size may be 1 gigabyte. It may be very big one. Okay. If you store the 4K or 8K data movie, maybe 10 gigabyte or 20 gigabyte. It's so big. Okay. And moreover, the microprocessor in your mobile phone is when it display or when we try to decode the movie, it may be a little bit lag or slow. Okay. The key of that is here. Okay. The key is if you sampling the data to few, the resolution that you get is not enough to decide your as your design. But if you sampling them too much, you waste the memory to store that. Okay. The next one is the mathematical model system. Yeah, the mathematical model system. Yeah. In the mathematical examination, the physical system or the physical signal can be constructed in the following figures. In the first step of the mathematical analysis, okay, the physical system is mathematically modeled by the mathematical equation. The mathematical equation is usually modeled by a physics law, maybe the Ohm's law, Kirchhoff voltage law, Kirchhoff current law, Newton law, thermodynamics law. Okay, as shown you in the previous section, previous example. Okay, the previous example I already showed you the model of the RLC in the series or RLC in the parallel. After you apply the KCL completely, you formulate them in the second order differential equation. Okay, or maybe explain them in apply the Newton law. It provides you the second order differential equation too. The next step in the second step of the mathematical analysis is a physical input signal are mathematically modeled by a mathematical function. Okay, function, sorry. Okay, function. In the last step, okay, last step of the mathematical analysis is the system equation are mathematically solved from the physical input signal, excited signal, or excited function in order to determine the physical output signal, response signal, or the response function. Okay, the overall idea of this system is here. You have the system. You maybe observe the phenomena, or you maybe have ROC circuit, or maybe any engineering system. You see them to be the black box. Okay. After that, you try to model them. Okay, to model them. Write them by apply the physics law in the conceptual aspects. Okay. Apply in the mathematical model of the system and the signal. Next one, you try to use the mathematics skill or the mathematical solution of this equation, and you convert them back, interpret them in the physics world. Now, in the real case, what happened? If the physics system is RLC, okay, in the parallel, you can apply the KCL. Okay, Kirchhoff current law, IC plus IR plus IL equal to 0. After that, you substitute IC, IR, and the IL, write them in the mathematical equation, formulate them. Okay, formulate them, simplify them. After you get the final equation, okay, you can solve them. Okay, the way to solve is based on the mathematics skill that you study from the calculus 1, calculus 2, and EEMAT. Okay, after that you get the second order equation is here. Okay, that in fact you know that the second order differential equation for the RLC circuit can be a category into 3 cases. Okay, the overdamp, underdamp, or the critical damp, and so on. Okay, but we may declare this first. Okay, after you get here, you can see that you formulate the first step, you formulate in the current, but the equation after you simplify them in the term of the voltage. You solve them in the term of the voltage or the capacitor voltage. Okay, after you solve them, you interpret them. Okay, what happened? The quality that you're seeking, the quality that have the key response of the other part is the capacitor voltage. For the second one is if you have the RLC in the series, RLC in the series, VL plus VR plus VC equal to 0. Okay. And okay, you can write VL in the term of IL, VR in the term of I, and VC in the term of I, as show you in the second equation here. After you simplify that, okay, you get the second order differential equation in the term of the inductor voltage. Okay, you know that how to solve them. You solve them in by using, okay, the second order differential equation that you get I in the term of here, okay, ES1T plus A2 ES2T. You get here, you can see that for the second one, even though the first step you formulate in the term of the voltage, but the response or the output will be in the solution will be in the term of the inductor current instead. Yeah, this is overall point of view. In general, the complexity of the mathematical equation depends on the accuracy of the system model. Therefore, if the system model have a high accuracy, okay, then the mathematical system equation traditionally have the high complexity too, which is cannot be mathematical so easily. Okay, such as the nonlinear multivariable differential equation, or maybe a differential equation that have a very high order. Okay, I think when you start during your study in the calculus, you have the ability to solve the differential equation order 2, 3, or 4, or 5 at most, right? But in the real case, it have some application to use to solve the differential equation. Yes, it has. For example, when you would like to run the rocket, okay, I think today everyone know about the Elon Musk, right? This guy is very famous one. Okay, he have the SpaceX company to run. Okay, the main objective is to try to create the colony in the Mars. Okay, the first step is the Elon Musk is here, but now he already tried to run the satellite around the world to ring to provide you about the internet. Okay, to ring at every place in the world. Okay, the low orbit satellite is deployed, starting to deploy by his plan. Okay, the key to run the rocket to deploy the satellite at least is required the differential equation order 26, 25 or 26 at least. Do you can solve by hand? I don't think so. Okay, if you would like to solve these differential equations order 20 or 26, okay, you must solve them by server computer instead. Okay. The last one is the example of the physics system. Okay, the example, the real example. This section presents the several examples of the physical system. Okay, every detail in the slide is already shown you in the book. Okay, post them in the book step by step, every word. Okay, you can read them, follow this step. Okay, in this case, we show you in the electrical circuit and the op-amp, operational amplifier circuit. This equation is a linear if the principle of superposition can be applied. Otherwise, the equation is non-linear. The non-linear definitions will be described in the later chapter. Yeah. The first one, we start by the example of the simple electrical resistance circuit first. Okay. For the simple electrical circuit as shown in this figure, the system equations can be modeled as the following equations when the input signal is the electrical current IT and the output signal is the electrical resistance voltage VT. Okay, I is the input, V is the output. Okay, we would like to find to ring between the input and the outputs. Okay, in this case, it's very easy. Okay, to ring between I and V. Okay, from the Ohm's law. The electrical circuits shown in this figure can be mathematical model by V equal to IR. R is the resistance value. Therefore, for this case, instead we draw them in the circuit detail. Okay, you can draw them in the block diagram here. Okay, if you feed the input, if the input is 5 amp, output is equal to R multiplied with 5. V is here. You can see that. This thing is the real circuit. This thing is the block diagram. Okay, that you can sketch it. This concept is the concept of the signal and system. You can see that when you see the real circuits, the real schematic, maybe the motor, transformer, the robot, the walker, the car, the airplane. We convert them into the block diagram. And we write the equation that relate between the input and the output that you interest, okay? The next one is the example of the simple circuit in here. For the simple theoretical circuit shown in this following figure, the system equation can be modeled as the following equation is here, when the input signal is the current and the output is the inductor's voltage. Okay, you can explain between V and I from the inductor's voltage and the current relationships. Okay, the theoretical circuit shown in these figures can be modeled by V equal to L di by dt, differentiate them. Okay, therefore in the block diagram, okay, you can see that, okay, the block diagram is show you if the input is I, output is V. You can find the relationship between V and I by this equation, V equal to L di by dt. The example of the simple electrical capacitance circuit is here. Okay, the circuit is the same as the previous, but we change the device to be the capacitor instead. We would like to find the relationship between V and I. Okay, from the capacitor voltage current relationships, okay, we can explain, we can describe VC in the term of I as show you in here. VC equal to 1 divided by C integrate I tau divided respect to tau. Okay, substitute the range from minus infinity to T. Okay, from this block diagram point of view, you can explain them in this block diagram. If the input is I, output is VC. Okay, the relationship between VC and I is by the integration operator. Okay, from these three examples, you can see that, okay, the relationship between the input is output is sometimes it's not simple like the amplifiers V equal to IR. Okay, maybe integration, maybe differentiation. Okay, or in another more complicated case. Okay, for example, in the op-amp. Okay, for the simple electrical circuit as shown in this following figure, the system equations can be modeled as the following equations when the input signal is electric voltage and the output signal is another electric voltage. Okay, here if the input is V, output if the input is here, we input, okay, output is V here. Okay, you would like to find between here. In this case, the operational amplifier perform right. Okay, about the amplifier depend on the value of these two resistors. Okay, from the ideals operational amplifier or from the ideal op-amp, the input current, okay, is here I equal to 0 volt, okay, and the output V equal to 0.2, okay, and the system equation for the input group can be expressed by here. Okay, we input, okay, equal to here in the input loop is here VD equal to 0. Therefore in this loop, okay, we input, okay, we apply the case VR, okay, we input an I and I input is here. You can explain I in the term of B input. And the next step, the system equation for the outer loop is can explain or can describe about the input and the output relationship. Okay, input and the output relationship is here. By apply the KVL to them, substitute them, give you here. I think the detail you already study in about the electronic subjects. Okay, therefore in this case, the ratio between the voltage input and the output depend on the ratio of the resistor input and the resistor output too. Okay, from the above equation, the resistor value must be positive and real number. Thus, the number, the ratio of the R output divided by the R input is the real positive and real too. Consequently, the term is minus R output divided by R input is the negative real number. Therefore, the above operational amplifier circuit is about the voltage amplifier with the gain equal to minus R output divided by R input. Yeah, in the overall point of view in here, if we assume that our input equals to 10, our output equal to 20, it means the output will be amplified the input by 2, but the magnitudes of them will be reversed, it's negative. Okay. Therefore, in the engineering point of view, we don't want to see about the diagram here. We would like to see about the block here. Okay, we don't want to care how many op-amp in here, how many resistors in here. We don't care. We don't like to know the relationship between the output and the input. And in this case, the output equal to minus 2 input of V input. Therefore, if the V equal to 0, okay, output equal to 0 2. If V equal to 1, if V input equal to 1 substitute is here. Output, okay, equal to minus 2 multiply 1 give you minus 2. And the last one, if the output equal, if the input equal to 0, output equal to 0 2. Okay, you can see that 0 minus 2, that's 0. Okay. Okay, moreover, the op-amp can do something more. For example, you can create the integrator circuit. Okay, and therefore it's following here. Okay, about the integrations operator. Therefore, the output equal to the integration of the input section instead. Okay, the detail of them. Okay, I think you already know it. You already try. You have the ability to find them in the electronic subject. I would like to link between the physics world and the mathematics world. Okay, the thing that we interest is here, output and the input. Explain them in a single closed form equation, or the differential of amp in the differential equation. Okay, we output equal to the differential equation of the input voltage. Okay, multiply with some constant. Okay, any question in the first this introduction?
No, sir.
Okay. Okay, this class maybe is only the introduction first. Okay, and okay, we will start the reals. Okay, the real content in the next time. Okay, because I think some of the student is cannot register completely yet or something like that. Don't worry about that. Okay. Okay. Therefore, maybe the first time, maybe either it means I don't want to teach about the content in the first time yet, because if some student is adding and maybe a little bit